In this video, we're going to look at how we are going to go from standard form to turning point form. This is, of course, now with a parabola. So just a reminder, standard form is y equal to ax squared plus bx plus c, whereas turning point form is y equal to ax plus p squared plus q. So sometimes they also say minus b here. Which one you see as standard form really doesn't matter. Or as turning point form with the plus p or the minus p doesn't really matter. The thing that you have to remember is if you have the turning point, the x value in being 5, then it will be x minus 5. Or if you have minus 6 as your turning point's x value, then it will be a plus 6 inside the bracket. That's all it's really about. Also, please note over here, there's some letter that is used in both, and that's A. That is because those A's are the same value, right? Okay, so if you are in standard form and you were given all three coefficients, well, the two coefficients and the constant term, then you already know what the A value is. Okay, so we are going to first do this now with completing the square, and then I'll show you another way that you can jump the system without knowing how to complete the square. Okay, so your first step is, you see here, we have our square term, our linear term, and our constant term. So we are just going to isolate the two terms that have our x, that have our variable. The constant term you leave outside the brackets. And so we already know our a is supposed to be on the outside of the bracket square. The on the inside is a 1. So the thing that's currently in your way is that 3. So 3 is going to be taken out as a common factor, and you make it like a big bracket. The minus 9 stays outside. So in this term, we have x squared left, and in this term, we have a plus 2x left. Then we're going to do some manipulation. So how this works is whatever that coefficient is, you are going to divide it by 2 and square it. Because whatever that term divided by 2 and squared is going to make that bracket a perfect square. So if you think of it this way, if you have x minus 3 squared and you multiply it out, you have x squared, then you have a minus 3x, another minus 3x, and a plus 9. Okay, you have minus 2 times 3x, which is also the shortcut. And if you look at this number, it is 3 squared. So this number that makes it a perfect square, or when you have a square multiplied out, that thing is, whatever is being squared to give you that number, is going to be half of whatever is here. So you essentially have like minus 6x plus 3 squared. So this number is half of that. Similarly, if you have x plus 5 squared, you would have x squared plus the two 5x's, okay, and plus 25. So you would have x squared plus 10x plus 5 being squared. So again, this is double that. So that is why you half it. You half whatever that number is. But you can't just add it. We can't just add something because it's convenient and we want to make a perfect square. But what you can add is a 0. Okay, the identity element of addition. So what you are going to do is you are going to add it because that's what you want. But you're also going to subtract that same thing. Whatever you added, you must also subtract. Okay, because then in essence, you are actually just adding 0. It's a manipulation. Remember, we manipulate maths, not people. But yeah, it's a manipulation. You are allowed to add 0 in this way that is convenient to you. Because this portion is now a perfect square. So this is what you can go and rewrite as a perfect square. But this term needs to go outside. So we're essentially basically multiplying the 3 with this, but you're keeping it a bracket, and multiplying the 3 with that other part. So we have 3 let's keep it as x squared plus 2x plus, this is 1 squared. I'm going to keep the square there just for a moment. And then minus 3 times 1. Okay, or you can say plus 3 times minus 1, minus 9. So this portion, that's minus 3 minus 9 is minus 12. So because this is a trinomial that can be written as a perfect square, your thing that you're going to write in the bracket is going to be whatever is being squared in front, whatever is being squared at the bottom. So basically the square root of it with that middle sign. So in other words, just like here, this one, you write as what is being squared with the middle term. Then you get back there. Same here. What is being squared in the front, what is being squared at the back with that middle term. You see it's the same as what we originally had. Okay. That is the way that you're going to do it with completing the square. But you don't have to use completing the square. Okay, you can just find the turning point and substitute it back in. So basically brute force. So firstly, we need an A, we need a P, and we need a Q. A we already have because it's the same A. So we already know A is 3. Then we find the turning point, which is minus P, Q. That X value is going to be your minus P basically, which is with minus B over 2A. Or you can find it with, if you have the two x-intercepts, adding them and dividing it by 2. So the midpoint between their two x-intercepts. We don't have the x-intercepts in this case. You can go calculate them if you really want to, but that's extra. So then minus b over 2a. So minus b was 6 here, so it's minus 6 over 2 times 3. So you get negative 1. Okay. So in other words, minus p is minus 1, so P is positive 1, which is what we got there. Similarly, your Q is basically your Y value, which is go substitute this back into the original equation. So the original equation, you go rewrite, but everywhere there were x's, you put brackets. And then you just go take that x value, not the P value, the x value you just calculated, the minus 1. That is the turning point. And you go substitute it in because basically at the turning point is negative 1 and then what we're going to calculate now. And then you're going to get negative 12. So your turning point is the point negative 1, negative 12. So if you want to go substitute it in, like brute forcing your way to turning point form, you didn't have to calculate. A was given to you as 3. Then this is the form. There's a minus 1, so it would be a plus 1. There's a minus 12, so it will stay a minus 12. And you see we get exactly the same answer. Okay. So again, our steps. We isolate our two terms that have the x's. We take out whatever the coefficient of x squared is as a common factor. And then we add and we subtract the middle term, well, the x terms coefficient divided by 2 being squared. We add them and we subtract them. The same thing. Then we just need to make sure this thingy that is being subtracted, that was just there because we can't just change willy-nilly what we want to. So that part you multiply with the term in front so it can come outside of the brackets. Then you have a perfect square, you rewrite them, add your constant terms there, and we are done. Okay, I hope this helped.